So let's try to add two number using a Turing machine. Okay, so in this lecture we are going to add two numbers using a Turing machine. So Turing machine will act as an adder here. So being a transducer, okay, it can act as a adder which will add two numbers, which take a two numbers as an input and produce an output. Okay, addition of it. So whenever we are trying to add two numbers, what is the various form in which we would represent the number? Okay, that we have to see. Okay, so the easiest way to represent a number is using a unary notation. Okay, unary notation. I will write here unary notation. That is the easiest way to represent this number. Okay, so what is unary notation is that if you take any number, okay, use only one symbol to represent that particular number. Okay, it can also be called as base 1. If you remember, in digital logic it is also called as a base 1. Okay, for example, for binary notation, it can be called as base 2. That means for any number, for representing any number, okay, any number, we will take two symbols. Here for any number we will take only one symbol. Okay, like this. For decimal we are using decimal, right, which is also called base 10. Okay, which is also called base 10. That means for any number, to represent any number, we will take 10 symbols. To represent any number, we will take 10 symbols. That is what base 10 is. Okay, so we are making use of unary notation for this particular query for addition of two numbers. Okay, so let's see how we are going to do it. So whenever I, for example, whenever I take number 3, okay, so I will represent it using any symbol, but I will represent it 3 times. For example, here in this case I am taking 1, so I will write 1 3 times. Okay, say you can take any symbol. Okay, you just have to define it. I can take 0 as a symbol and I will represent it 3 times. Okay, or I can take dollar, but I will write it 3 times. That is what unary. Or I can take at the rate, okay, but I will write it 3 times. So any of the symbol you can take it, but okay, but it, when I'm using a number 3, it should represent using a 3 times. Okay, so you have to repeat it 3 times, that particular symbol, then it becomes number 3. It will represent 3 number in unary. Okay, for example, if I am taking 4, then I have to repeat 1 4 times. 1 2 3 4. Are you getting it? If I take 5, then I have to repeat 1 5 times. 1 2 3 4 5. Okay, this is how you will represent any number using a unary notation. Okay, so like this, if you take 6, then to represent 6 in unary, you have to take 6 ones. 1 2 3 4 5 6. Like this, if you take 7, then you have to represent is using 7 ones. 1 2 3 4 5 6 7. Okay, so in unary it will represent, okay, when you repeat it 7 times 1, then it becomes 7. So first thing we are going to see is how we are going to represent input. Okay, and how does our output look like, which means after adding two numbers, how should the resulting number will look like. Now if you observe carefully, here the length of the string, okay, the length of the string, for example, if I am consider the length of the string as x, this entire string. For example, if I consider this entire one as string, okay, or if I take this 4 as an example, I will consider this entire one as string. Okay, this one entire one I will consider a string. Okay, now if we have a number 4, then it will be represented as 4 ones, right? It will represent, if I take number 4, then it will be represented as 4 ones, right? Then if I consider this string, this 4 1 as one string, okay, and I will consider it as x, then the length of this string, then the length of this x, that means this particular string, okay, itself become a number. What is the length of the string? Length of the string is 4. So this length of the string itself become a number. Okay, so this is what something we can observe here in this string. Okay, so this property we can make use of for building a logic. I hope you understood. The length of this string itself become a number. For example, this is a string x. Okay, I'm consider this entire one as a string x, and then the length of the string become a, what is the length of the string? Just count number of ones, 1 2 3 4, that is the length. So the length of x become 4. So the length of the string itself become a number. Now we want to add any two numbers and produce a result, right? Now the question is, how should we give an input to the Turing machine? That is the question. How should we give an input to the Turing machine? So we will see that part. Now we will see the example where we are going to take two numbers. So I'm taking p as 3 and q as 4. Okay, so I can't directly give this 3 and 4 directly to the Turing machine. I have to convert into unary notation. So how can I convert into unary notation? I will take one symbol and repeat it 3 times. So 1 2 3. I will take 4 symbol and repeat for inputting 4 inside a Turing machine. I will take one symbol and repeat it 4 times. 1 2 3 4. Okay, so these 3 ones will represent 3 and these 4 ones will represent 4 inside a Turing machine tape. Okay, now in the result, what we want is, what we want is p plus q, that is 3 plus 4 equal to 7. That is one symbol repeated 7 times, and this should be there in your output. Okay, and this should be there in your output, means it should be present inside the tape of a Turing machine. Okay, so after this particular addition of 3 and 4, this 7 times repeating once, okay, one symbol repeated 7 times, this should be there inside the tape of a Turing machine. So let's see how we can build a logic for generating this output. Okay, addition of this 3 and 4. Okay, so for Turing machine tape, inside the Turing machine, how we will store this input is, see this part which is p, okay, we will store it using a 3 ones. Okay, and this part which is q, okay, we will store it using a 4 ones, right? And this 0 symbol we will use as a separator. Okay, separator between 3 and 4, right? And what the logic we will do is, we will remove this 0. Okay, we will remove completely this 0 from this particular string and concatenate this p and q. This p and q we will concat. Okay, then after that, whatever the result we will get will be 7 ones, right? 7 ones. So this is nothing but concatenating two strings of ones by removing 0 from the middle. What I mean is concatenating two strings of ones by removing 0 from the middle. Okay, so this is the logic we are going to do, but we have to see how we can do this, okay, using a Turing machine. So let's see how we can build a logic for this. Okay, so what we can do is that whenever your read write head is pointing here, right? So whenever you see 1, okay, whenever you see 1, keep it as 1 as it is. Okay, whenever you see 1, keep it as 1 as it is, and move in a, this is left, this is right, right? Move in a right direction. Okay, Again, whenever you see 1, keep it as 1 it is, then move in right direction. Okay, again you see 1, move in right direction, keep it as 1 and move in right direction. And whenever you see 0, make it as 1. Okay, make it as 1 and move in right direction. Okay, because this 0 is working as a separator, right? Make it as 1. Then again move in right direction, and whenever again you see 1, make it as 1. Again you see 1, make it as 1, 1, make it as 1, and keep on moving in right direction. And then you will suddenly hit the blank. Okay, whenever you hit the blank, move in, turn in left direction. Okay, and start moving in left direction. And that means what does it mean? When you hit the blank, that means all the input string is over, right? That means all the input string is over. So turn left, move in left direction, and whenever you see the first symbol, make it blank. Make this symbol as blank, because you already incremented 1 here by making this 0 as 1, right? That's why you decremented it by making this 1 as blank. Okay, now if you count it in the output string, 1, 2, 3, 4, 5, 6, 7. There are 7 ones. Okay, inside this tape, Turing machine tape. So at the end we get one symbol which is repeated 7 times as an output. Exactly what we needed. Okay, so this is what we get as an output at the end. So Turing machine will understand that your answer is 7. So it will produce an answer as 7. So let's see how we can design this Turing machine. I hope you understood the logic. So let's see how we can design a Turing machine for this particular logic. So we will take an initial state Q node. Okay, and what is the rule? Whenever you see 1, keep it as 1 and move in right direction, right? And you keep on moving in right direction unless and until you see the 0. So whenever you see the 0, okay, convert into 1 and move in right direction. Okay, move in right direction. Then after that you are in Q1. After that, again, how many number of ones you see, keep it as 1 as it is. Okay, so whenever after this 0 converting into 1, whenever you see 1, okay, keep it as 1 and move in right direction. Okay, after that you keep on moving in right direction, and then suddenly you will hit the blank, this part. Sorry, this is 1 already, na? So you will hit the blank here. So whenever you hit the blank, you keep it as blank and move in left direction. You can see, move in left direction. Okay, after now you are here, right? After that you have to move in left direction, and whenever you find the first symbol, okay, which is 1, okay, make it as blank and keep on moving in right direction. Okay, and after that you have to keep on moving in right direction. I told you, you have to again point the read write head to the first position where it is started. So for that I'm keep on moving in right direction. So whenever you see 1, keep it as 1 and move in, sorry, I mean left direction. Okay, this is the mistake I done. You have to keep on moving in left direction. Okay, this is left, right? So whenever you see 1, make it as blank and move in left direction. So whenever you see 1, make it as blank and move in left direction. And after that you have to keep on moving in left direction. Okay, you have to keep on moving in left direction. then after that you will suddenly hit the blank. Okay, when you're moving in left direction, you suddenly hit the blank. Okay, so whenever you hit the blank, just turn right or left wherever it is. Okay, and stop there. So this is the Turing machine which we are constructed. Okay, so at the end we can see there are 7 ones inside the tape. So length of the string is the number of ones, and the length of the string itself represents the number itself, right? The length of the string is number of ones. I will write here, the length of the string is number of ones. Length of the string is number of ones, and length of the string itself, and the length of the string so we can see that the length of the string is a number of ones, and the length of the string itself represents the number. Okay, so at the end of the Turing machine we will get 7 ones inside our tape, and that 7 represent the output, that is 3 plus 4 is equal to 7. So there would be 7 ones inside the output, and as I said here, the length of the string itself represents a number, so we will consider as a 7, because it is 7 is represented as a unary notation inside a binary inside a Turing machine. Okay, so that's why it will consider as a 7 as an output. So exactly, so hope you understood. I'm just repeating it again. So whenever you see 1, okay, so if you see this Turing machine properly, whenever you see 1, keep it as 1. Okay, move in right direction, and whenever you encounter 0, make it as 1. Okay, make it as 1 and move in right direction, and keep on moving. And after that, whenever you see 1, keep on moving in right direction. That is what we are doing it. We keep on moving in right direction unless and until you hit the blank. So whenever you hit the blank, okay, whenever you hit the blank, this in this case this was 1 previously, so it was 1, right? So whenever you hit the blank here, okay, you will move in left direction, then you will turn in left direction, and after that, turning in left direction, you will find the first symbol as 1. Okay, so whenever you find the first symbol as 1, make it as blank. Okay, then move in left direction, and after that you will find many ones, okay, in the way. So whatever one we will find, we will make it as 1 and keep on moving in left direction. We will cross all the ones, and suddenly we will hit the blank in leftmost direction. Okay, when you are moving in leftmost direction, so when you hit the blank, okay, just turn right and stop there, turn right and stop there. Okay, so your read write head will point at the beginning of the Turing machine, beginning of the symbol. So that is what I and the result will be 7 ones. So hope you understood.